episode of the Energy Central Power Perspectives podcast. Located in New York City, I'm your host, Jason Price, in the Energy and Utility Practice of West Monroe and Community Engagement Ambassador for Energy Central. I'm joined by my colleague located in Orlando, Florida, Matt Chester, Community Manager for Energy Central. Hello, Matt. Are you ready for today's guest?
Absolutely, Jason. I know he has so much to share from his expertise and experience in the field, so my only real question is how we can fit it all into one episode.
Absolutely. For our listeners, we are recording this episode at the height of the coronavirus epidemic in the United States, though you are likely listening to this a number of weeks after we first recorded it. Early in my professional career, I was an epidemiologist working at an AIDS center in Boston. This was in the early 1990s. The study of epidemiology is the study of population health. Epidemiologists, like those at the CDC, look at the behavior of a disease and combine statistics with tools like geographic data to understand the location, growth pattern, and movement of an outbreak. The same approach is being deployed today to fight COVID-19. However, the tools used are far more sophisticated than they were 30 years ago. Experts in GIS, or Geographic Information Systems, at the utilities are trained professionals who similarly monitor and track the spread of utility assets throughout a geographic location. They are charged with identifying patterns, locating trouble spots, deploying mitigating strategies, and providing guidance to the field agents in monitoring the health of the energy network. You could describe these GIS experts as the epidemiologists of your local electric, gas, or water utility. They're constantly monitoring the network, trying to identify patterns of disruption, and are often the first to raise the alarm on a failing asset. A leader in the field of geographic mapping technology and GIS is Esri. Esri is an international supplier of geographic information systems and geodatabase management applications. The company is headquartered in Redlands, California. With us today is Pat Hohl, Esri's Director of Electric Industry Solutions. Pat oversees the planning and execution of Esri's go-to-market strategies in the electric utility industry. He is a pioneer in the use of GIS for electric utilities and has over 35 years of progressive experience in engineering, technology, operations, and executive management. Pat is an industry thought leader, and he generously shares his knowledge as an author, consultant, and university professor. Pat has also been an Energy Central member since 2018 with 46 postings to the site and over 73,000 views of his work. Pat Hohl, we are privileged to have you here on the Power Perspectives podcast. Welcome.
Thank you very much for having me. It's a pleasure to join you today.
Pat, let's begin with why you're here. You posted on Energy Central a 3-part series called 3 Ways Distribution Circuits Will Disappoint You. It inspired some notable discussion within the Energy Central community. Summarize the series, if you will, and what compelled you to write on these critical pieces of equipment to the energy industry.
Sure, it's a pretty good story. I was visiting a good friend of mine, Pat Hohl, and we sat in his backyard discussing, among other things, the future of utilities. And as we talked about things, he pressed me. He said, "You've been around the business for a long time. What do you think the circuits will look like in the future?" And that caused me to stop and think. I think most of the listeners will recognize that electric utilities divide their distribution system into circuits or feeders. And as an industry, we love our circuits. We manage our whole system that way. And in fact, we normally give them names, usually after the substation that they feed from, like Newtown 6, or sometimes numbers like 1215. But we do almost everything by circuit. We map by circuit, we patrol by circuit, we trim our trees, we even report statistics, all by circuit. And traditionally, those circuits feed from a substation and deliver power to customers in a one-way flow. So as I thought about this question, I realized that going forward, circuits are really going to need to morph into more of an interconnected network. And I think network is really a much better term than circuits to describe the future state of the modern grid. I think everybody recognizes that utilities are changing pretty rapidly, and so is this idea of circuits. But sometimes the circuits are not changing all that quickly. There's a large set of infrastructure out there, and there's a lot of stationary momentum to overcome in terms of upgrading all that equipment. Well, if we're going to realize the promise of grid modernization, the circuits are going to have to change too. So I went back from that discussion, and I quite literally filled a whiteboard with ideas, and I looked for commonality, and I tried to boil that down to a couple of points, and I realized it would make a very good blog to write about. But it was long, so I decided to try doing it as a 3-part series, and people seem to have liked it. I like to give my pieces intriguing titles, so I poked at our built-in affinity for those beloved circuits by kind of startling people 3 ways that distribution circuits will disappoint you. And those circuits are going to let you down if they don't change. So to avoid disappointment, the circuits of the future are going to have some important differences, and I divided it into three pieces. They're going to have to operate in smaller pieces. They're going to have greater complexity, and they're going to change more rapidly than we're used to.
Pat, can you expand on those 3 things?
Yeah, so the first one is smaller pieces. In the future, these electric networks are going to need to be able to break down into smaller pieces so that they have greater operating flexibility. If you think about all the things that are coming into the distribution system that weren't there before, like distributed energy resources and electric vehicles and automation, the range of possible operating conditions is just exploding. And so to accommodate those, we're going to need to be able to divide things into smaller pieces. Typically, circuits get divided up so we can sectionalize, isolate trouble, minimize the impact of a problem to numerous customers, or just perform maintenance tasks. But utilities are now going to need more flexibility to accommodate different kinds of customer usage and also power generation. When we think about renewables, wind and solar are both variable types of resources. Circuits were designed for one-way power flow from a substation out to all of the customers. And so the networks will need to be able to divide up and switch around in smaller pieces that will create the flexibility to handle these different kind of power flows. Think of it like this: networks have to be more configurable than circuits to meet the needs of tomorrow's customers. Smaller pieces. The second thing is the greater complexity. If you look at the sheer volume of electric system devices that I saw at Distributech this year, the type of devices are going through the roof. And it's an important insight to realize that most circuits across the country are starting from a fairly low level of sophistication. Probably the most common protective device out there is a common fuse. And a fuse is just a skinny little piece of wire that may sit there and do its job for decades until it's needed to protect the circuit. And then its job is to just burn in half. It's a very simple device. Of course, someone has to then go change it. Very reliable, but very low tech. Now we're adding microgrids, vehicle-to-grid supplies, smart inverters, IoT sensors, and in the place of those fuses, automatic switches that have to communicate and are oftentimes controlled by some form of electronic controller. And that operation is based on the actual conditions of the network as it exists right now in real time. So those kind of devices all bring much more sophistication than are commonly used today, and they all bring greater complexity. So based on my experience, when I think about complexity, I recognize that that's going to bring all kinds of new challenges for a utility in terms of their record keeping and workforce development, maintenance, operations. Even troubleshooting is going to take on a whole new flavor. And without getting too technical, these kind of devices, they have more points of connection, and they have test provisions and bypass functions, and all of these things need to be accounted for and particularly modeled as we consider how to operate such a network. Finally, the rapid changes. Traditional circuits, they tend to be very static. In fact, in my experience, most engineers and operating personnel often have the circuit memorized. If they know that they're going to the corner of 5th and Market, they know which circuit that is, they know where it feeds from, they know what fuses are upstream. And circuits tend to only change for work tasks, or in some parts of the country, they change between summer and winter configurations. But when we add self-healing capabilities and power flow that reverses, smaller pieces and automatic switches, all of these things are going to require networks to change more rapidly. Now, things are also able to change automatically without any human interaction, or with a little human interaction. Changes that may be made to the system without being announced on the company's two-way radio system like would normally have been done. In fact, if you think about the way that this could go in a sort of a worst case scenario, a network could change and then it could change back to the way it was in just a short period of time. So it's going to be very important that people are able to model that and keep track of that, because I worked in operations for many years. When things change quickly, they quickly become a safety concern. You can't operate a complex, rapidly changing network from a coffee-stained set of last month's paper maps that are in the back of your truck. So engineers and line workers alike are going to need near real-time information. They're going to need it at their fingertips, because rapid changes spark new safety concerns and requires special work procedures just to manage those.
Pat, change is a common theme in your articles. You even evoke Bill Gates when he notes that we always overestimate the change that will occur in the next 2 years and always underestimate the change that will occur in the next 10 years. Can you speak to how this applies to the utility business overall?
Sure, I like that quote from Bill Gates. And, understandably, much of the industry focus and press is on the high-profile political and even regulatory issues, energy transition and things like Tesla battery storage and distributed resources. These are all increasing dramatically, and we think about them a lot. And new dramatic issues tend to make us think that everything will get turned upside down overnight. Bill Gates' point is that we tend to overestimate how much of that will happen in the short term. And with few exceptions, electric vehicles aren't going to upset the apple cart in the short run. But that change is in motion. And after 10 years of change, that will be pretty significant. So his point is, don't lose sight of that. Over a longer period of time, those changes are going to be significant. And he ends that quote by saying, don't be lulled into inaction. I think that's great advice for utilities. Prepare now for what's coming down the road.
That's great. Pat, in the first article, for example, you talked about a professor you once had who declared that nothing had changed in power engineering since the 1930s, but how that sentiment was now laughable when looking at the modern utility. When it comes to adapting to the dynamic world we live in today, what do you think utilities need to do to adapt and stay agile?
Well, that's a great question. My friend Pat had a good laugh when I said that. Remember I went to college in the early 80s when there was no internet and no PCs. And when my professor said that, there's nothing new in the electric engineering power industry since the 30s. He was trying to help us come to terms with some difficult concepts and math. He was reminding us that physics was still the same and that the principles that underlie those things were also unchanged. But things have changed now, and we're in an interconnected world, and computers are taking us to places that we never envisioned in the 80s. And so this idea of the network becoming the most important utility asset is really key, because it's going to enable new business models and new types of customer value that we haven't even really thought of yet. It's entirely possible that our beloved circuits are going to move from a one-way delivery path into more of a marketplace for people to participate in, connecting prosumers and all of the generation sources that will exist at any point in time. So successful utilities are going to have to adapt in order to be relevant into the future? This is the question that everyone should be thinking about. How is your utility preparing to successfully operate the circuits of the future?
Let's turn now to Esri. The company's motto is the science of where, which is fitting given that the company develops locational data and geographic information systems. What would you say is the core focus of Esri?
Esri was founded to help solve some of the world's most difficult problems, and it does that by supporting our users' work in over 350,000 organizations worldwide. We're committed to science and sustainability and positive change. But one thing that really sets Esri apart is research. We spend more than 30% of our annual revenue on research and development. 30%, that's unheard of. We're really committed to serving our customers and working together on solutions to the challenges that they face, challenges like network modeling, analyzing data, and then sharing all of those insights with everyone in the organization that needs business intelligence.
Pat, I came across the ARGIS link tracking COVID-19, which we can post on the Energy Central website for our readers. Is this a typical non-energy use of your technology, or are you quite surprised at how GIS is applied outside of the energy space? And what portion of customers outside of the energy and utility industry are using your technology?
Just to touch on COVID-19 for a moment, everything about a pandemic revolves around where things are happening. We have all watched the spread of this virus on a daily basis. We see the locations of cases and people, resources, treatment. Those things are all critical. And similarly, most utility concerns hinge on this idea of location, where things happen. Customers, assets, crews, weather, materials, they're all somewhere. And where things are matters for utilities and customers. To get to your question, about 85% of Esri users are actually outside the utility space in almost every industry that you can think of. National and local government, healthcare, commercial, education, even nonprofit organizations. And given the very broad use of GIS and Esri's location technology, I'm not surprised at all. I expected it from a modern GIS. And I'd like to just touch for a moment on this idea of a modern GIS. Many people still think of GIS the way that they did many years ago. It's a great way to make better maps faster. And if that was all it did, Esri wouldn't be in the forefront of the COVID-19 fight and in all these other industries too. Today, a modern GIS really does so much more. It incorporates nearly every kind of data that you can think of: imagery, LiDAR, IoT feeds, weather. And with location as the binder, it helps find the meaning from that data and deliver a common understanding to the entire enterprise, whether that's an executive dashboard or it's the employee in the trouble truck who's trying to troubleshoot a problem. And when I say find meaning, it does that with the very latest set of analytics and artificial intelligence, using machine learning, making predictions, even augmented reality. It's really quite remarkable. I think that people want information that fits their role, and they want it to be convenient, and they want it to be timely, just like the apps that they use on their phone in their everyday life. They want to see information in their browser or right there on their device. And a modern GIS delivers that kind of information with a comprehensive security model that fits into the IT structure of the organization and with a rules engine that is built in that enforces data quality. And utilities that are not leveraging all those capabilities are missing out. So as we look at the virus impact on utility work just for a moment, we see all kinds of changes happening already. Work crews are taking separate vehicles to the job site. Many people are working from home. It's blowing up this whole idea of paperwork, and our customers are asking for new and better ways to communicate and collaborate and share this kind of information that we've talked about throughout the organization. It's really a very exciting time because we're going to be forced into improving utility communication and collaboration and breaking down silos within those organizations in a very short period of time.
Absolutely. Pat, the work of Esri is just absolutely a tremendous value for the industry. We want to give you the last word. What would you like our listeners to walk away with?
I would like listeners to think about their own modernization goals and how their circuits will have to change, and consider the role of data, specifically the network model, in their vision of the grid of the future. I think of grid modernization as a journey, not really a destination. Many of the things that we need are still in development. But as we evolve as an industry, we don't want to be disappointed by our circuits. And we already see the writing on the wall. We need to evolve with those circuits and be able to model the robust network of the future. And Esri's developed a state-of-the-art network model. We've listened to the things that our customers have been asking for all over the world. Our current network modeling capability is really an enabling technology that's ready to take utilities and their circuits into the future of a modern grid.
Pat Hohl, I want to thank you for your time and for this fascinating discussion. You can always reach Pat through the Energy Central platform, where he welcomes your questions and comments. Energy Central's podcast, The Power Perspectives, would not be possible if it were not for our devoted sponsors, including West Monroe. West Monroe works with the nation's largest investor-owned utilities in their telecommunication, grid modernization, and digital and workforce transformations. From defending a rate case to preparing a business case, West Monroe utilizes a multidisciplinary team that blends utility, operations, and technology expertise, covering topics like aging infrastructure, electric vehicles, AMI, MDM, and ADMS deployment, and industry disruptors like DERs and cybersecurity. To Esri, the Environmental System Research Institute, Esri is an international supplier of geographic information, GIS software, WebGIS, and geodatabase management applications. To Guidehouse, formerly Navigant, a leading global provider of consulting services to the public and commercial markets with expertise in energy, sustainability, and infrastructure. And to C-Power. At C-Power, we help customers make the decisions today that guide them across the bridge to energy's future. Where will your energy take you? For more information, visit C-Power. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at EnergyCentral.com. And see you next time at the Energy Central Power Perspective Podcast.